What's happening, dogs? Mr. Allen here with a video on transformations of functions given our parent linear function f of x equals x. We're going to describe these transformations. We're going to list our y-intercept rate of change or slope, and we're going to determine if the new function is parallel to the original, and maybe some other mathematical freebies along the way. All right, first one here. We have f of x plus 2, right? And the 2 is on the outside. So that's going to go up 2, all right? So we're moving up 2. So what's my y-intercept? Well, if it started at 0, 0, then my y-intercept is going to be at 0, 2. I moved up from 0, 0 to 0, 2. Nice. All right. What about my slope, right? Or my rate of change? We'll say slope. All right. So what's my slope going to be? Well, I didn't multiply this function by anything, right? So it's still just going to be 1. Okay? So if it started out like this, it's going to stay like that. I would just really be getting, actually, I'll write the function down here. Our new one, let's call this, say, g of x. G of x would end up equaling x plus 2. That would shift it up 2, right? There we go. Now, next thing, is it parallel to the original? Is my slope the same? Yes, then it is parallel. Check, I guess. All right, cool. Next one here. We got 4. F of x. All right. Well, that's a vertical stretch by 4. Okay, I didn't want to run out of too much room there, so I kept it in one line. Vertical stretch by 4. Some might say a vertical dilation by 4. Is that going to change my y-intercept? No, I'm just going to get steep real fast. So my y-intercept is still 0, 0. All right. My slope, however, check this out. I think I'm going to rewrite this one down here, just like we did before. We'll call this h of x this time. So my h of x, that's going to be 4 times x, right? It's 4 times the function. Our function being the linear function here. So this guy gets multiplied by 4. All right. So my slope is now 4. And are we parallel? If we have a different slope, not parallel. Very good. Does this pass through the origin? Yeah, it does, right? It's 0, 0. Okay, those are other questions they can ask. You know, maybe they're just asking some fun things. All right, next one. I'm going to go back to orange. I'm going to alternate, I think. We'll see. Who knows? Who knows what I'm doing later on? I don't even know, man. We'll call this one H-I. Nah, maybe not I-J. I'm going to go N of X. I don't know why. Because it felt like it. All right. So now I have a vertical compression. A vertical compression by 1/3. So vertical compression by 1/3. And they may or may not ask you for those transformations at this point. I'm going for it because I love mathing, right? They might only ask for these few things right here. But in talking transformations, that is a vertical compression by 1/3. The compression's outside of the function, so cool. If it was inside there, then we start dealing with horizontal. We're not going to talk about that yet. Okay. Y-intercept. I didn't move up or down, right? I'm just compressing it. So my y-intercept stays the same at 0, 0, just like my parent function right up there. It's going to stay 0, 0. My slope, however, if you can think back to this one here, the slope became 4. Now my slope's going to be 1/3. And at this point, why don't I go ahead and write my n of x function here, 1/3 x. There we go. Is it going to be parallel? Different slope, bro. Not parallel. Not parallel. Awesome. All right, and the last one here. I will switch back to pink here for this one. Last one. That is a shift to the left 3. It's opposite of what you'd think it would be on the inside, so we're going to go left 3. Okay, well, how is that going to change my y-intercept? This is kind of a little bit tricky. I'm gonna just graph something right down here, okay? So this is for our new guy here. If I'm going to take my normal y equals x or f of x equals x, and I move it to the left 3, 1, 2, 3, I didn't change the slope, so I'm going to be up 1, 2, 3 as well. Oh, so my y-intercept, that is terrible, is 0, 3. Cool. All right, there we go. So I shifted it to the left 3, which then is going to hit up at positive 3 up there. Lovely. Fantastic and wonderful. All right, how about my slope? Slope That doesn't change here for this one, so it's still 1. And I'll go ahead and write, we'll call this guy, I don't think I can write right there. We'll say this one's m of x. I don't know why I went n first and then m, but we'll go for it. I'm going to write it down here. M of x is equal to, it's going to be, let's see here, x plus 3. It's interesting. With linear equations, it kind of looks almost like it was a vertical, shift, up 3 on this one. But yeah, in the equation, it does look the same when you're dealing with linear equations. It's kind of weird, but as you get into like quadratics and exponentials, you'll start to see some differences there. So, but with linears, they're kind of their own little beast, because if I move to the left 3, it also is going to look like it moved up 3. So I wouldn't ask you, what's our transformation for this one? We would accept left 3 or up 3, really, for that transformation, right? Okay, and is it parallel? Heck yeah, it is. It is parallel. Boom. Nice. That's awesome, man. All right, so we can give you any one of these kinds of things here and ask you to list, what the new function is, what the transformations are, the y-intercept, the rate of change, whatever it may be. A lot of different questions you can ask based on these right here. We could even just not give you this guy right here and ask you these same questions. We wouldn't be able to ask for like the y-intercept, but we could still ask for, if it's parallel, because you would be able to determine your slope. And I can also ask you like the transformations. All right, there we go, man. So that's dope. Awesome. Fantastic. You guys are fantastic. See you later.